Hey, what's up? Welcome to Best Explanation. This video is about equivalent fractions. So I'm going to make an illustration here. I'm going to use some examples to illustrate what equivalent fractions are and how you can work with them. So here we go. Equivalent fractions. I'm just going to list out a few. All right. So think about 1/2. 1/2 equals 2/4, which equals 3/6, which equals 4/8. Now, there's two ways that I can think about why these are equivalent fractions. The first way is just to recognize that every single one of these fractions shares the same ratio from its top to the bottom. So, in other words, the more technical way of saying that is that the ratio between the numerator and the denominator is the same. See? You see how 1 to 2 is the same as 2 to 4, same as 3 to 6, 4 to 8? Because 2 is twice as big as 1, 4 is twice as big as 2, 6 is twice as big as 3. So the common ratio that these all share between the top and bottom is 2. And that's how I know they're equivalent fractions mathematically. But let me illustrate this using a diagram, and I think that this will give you a little better intuitive understanding of why these are equivalent. So if I drew 1/2, you see how I would get a picture like this? Because 1 is the number of pieces I have filled in, and 2 is the total number of pieces I have. So 1 out of 2. 1 out of 2. Okay. If I drew 2/4, I would get 4 pieces, and 2 of them would be filled in. Because 2 over 4. 2 out of 4 total. Now notice something. Do you see how this picture is exactly the same as this picture in terms of the total area filled in? What that means is that since the area filled in is the same between these two pictures, these fractions must be equal. And so this is just sort of a pictorial demonstration of equivalent fractions. And I could do the same thing with 3/6. See, if I take 3/6 and I draw it, I'm not a very good artist here, but bear with me. I fill in 3 of the pieces. You see how it's also the same? In any case, and I could do it with 4/8 too, but I'm not even going to try to draw that. So this is basically the conceptual basis of equivalent fractions, right? So now we come to the question of what are they used for? Well, they're used for adding and subtracting fractions. They're used for simplifying. They're used for all kinds of stuff. And you really just want to understand what to do with them when you see them. So I'm going to just give some example problems here and see if you can follow along with me, right? So if I said, here's an example. If I said find an equivalent fraction of 5/8. 5/8 equals something, right? We need to find an equivalent fraction that's the same as 5/8. Well, one really easy way to do that is to just pick a number, any number, and then multiply the top and bottom of this fraction by that same number. So how about 3? Okay, if I just pick 3, I want to take this equivalent fraction, I want to scale up the top and bottom by a factor of 3. I go 3 times 5 is 15, and 3 times 8 is 24. So the fact that I multiplied the top and bottom of this fraction by the same number is why I got an equivalent fraction. That's it's a very important thing to understand. And just like I can multiply top and bottom like this, times 3 times 3, and get an equivalent fraction, I can do the same thing. I can go backwards. I can divide. See? Because do you see how if I went 15 divided by 3, I'd get 5, and 24 divided by 3, I could get 8? So you usually don't make fractions more complicated like this. Usually it's the division. I just want to illustrate that it goes both ways. So here's like a real-world problem that you might actually encounter. Let's say that we had something like this. We had, I don't know, 8/16, and we're trying to subtract, I don't know, how about 6/32. So this is adding and subtracting fractions kind of problem, and if you really want to go in depth on this, then go check out my video on adding and subtracting fractions. But I'm just going to use this as an example real quick because I think it is a very good way to illustrate the use of equivalent fractions. So right here you can't do this, right? Because these have a different denominator. So what you need to do is you need to take this. If you take 6/32 and you rewrite it as an equivalent fraction, you can actually do it. Because notice, you see how if I take 6 and I take 32, do you see how if I cut both of these in half, it's going to do something sort of useful for me? Watch this. So instead of 8/16 minus 6/32, I'm going to have 8/16 minus 3/16. So how did I just turn 6/32 into 3/16? Well, it's simple. I took the top and I went divided by 2. And I took the bottom and I went divided by 2. And since I divided the top and bottom by the same number, that's legal. I was able to do that. So now I can actually do this problem. I end up with 5/16. And like I said, this is not a video on subtracting fractions, but I just thought that this would be a good illustration of what equivalent fractions are used for. So anyways, yeah, basically what I guess as an overview I would say is that equivalent fractions are just different ways of writing the same thing. So there's really not much to this when it comes into actually doing the calculations with it, but it's the conceptual framework that I think is really important in this case, because that's how you'll really understand this in the long run. So anyways, thanks for watching, and please subscribe and check out my other videos if you get the chance.